So the next several reactions we're going to look at are going to be involving not just benzene itself, but the side chain reactions of benzene, and specifically a couple of these, the benzylic position. And in this case, we're going to look at oxidation first, and you can do this with either permanganate or chromic acid. So with permanganate, you do it two steps. You do it under basic conditions with potassium permanganate, really hot, and then you just protonate the resulting carboxylates that form to make carboxylic acids. Or you can do this with chromic acid, and again, the most common way you'll see chromic acid is sodium dichromate with sulfuric acid, or any real acid anyways, any aqueous acid. Either way, either set of reagents, we're going to accomplish the same thing. So if you look, we got a benzylic carbon there, a benzylic carbon there, and a benzylic carbon there. So if we look at the fate of each of these, now this benzylic carbon is this one right here becomes a carboxylic acid. Okay, that's easy enough to explain. But this benzylic carbon right here becomes this one right here. And the idea is that any carbon besides the benzylic one gets cleaved off. So this also involves oxidative cleavage here. So that explains that one. Now, this benzylic carbon right here doesn't react. So it turns out part of the mechanism is that carbon has to be bonded to a hydrogen. And so for a quaternary carbon here, he's not bonded to any hydrogens and therefore is completely unreactive. And so the T-butyl group here is completely untouched in this side chain oxidation. So again, we're oxidizing benzylic carbons, but they have to have a hydrogen, and any carbons beside the benzylic get completely cleaved off, and then the benzylic gets oxidized to a carboxylic acid. That's the plan.